Welcome to the DIY Honda Garage channel. The DTC P0172 indicates a rich fuel condition in the fuel system of a Honda Civic model from 2011 to 2015. A rich fuel condition occurs when there is an excess of fuel relative to the amount of air in the combustion chamber, leading to inefficient engine performance and increased emissions. This code requires immediate attention as it can damage the engine if left unresolved. The Diagnostic Trouble Code triggers caution regarding the status of various sensors, particularly the mass airflow, MAF, and air-fuel, AF sensors. Understanding this DTC involves diagnostic methodologies that start with basic engine parameters, moving towards specific sensor evaluations, fuel system checks, and ultimately identifying any necessary repairs. Accurate troubleshooting is crucial to prevent further complications and maintain vehicle performance. The DTC P0172 signifies a rich fuel condition that can affect performance and emissions in your Honda Civic. Affected components include the mass airflow, MAF sensor, which measures the volume of air entering the engine and significantly influences fuel delivery. The air-fuel, AF sensor, responsible for monitoring the air-fuel mixture for optimal combustion, and the engine control module, ECM, which regulates these components based on collected data. The MAF sensor is typically located in the intake air duct before the throttle body, while the AF sensor is positioned in the exhaust system, usually before the catalytic converter, to assess combustion efficiency. Ensuring these parts are functioning correctly is vital for resolving the DTC and achieving proper air-fuel mixture ratios. There are several possible causes for the DTC P0172, which include aftermarket components that may interfere with the engine's standard operation and lead to a rich condition. Faulty sensors such as the MAF or AF sensors can provide inaccurate readings to the ECM. This can result in incorrect air-fuel mixture adjustments. Irregular fuel pressure is another critical factor. If the pressure is too high, it can lead to excessive fuel delivery. Notably, this code may trigger alongside other DTCs, which should be diagnosed first to prevent overlooking interconnected issues. As these causes are explored, it's essential not to clear the DTC prematurely, as valuable diagnostic data may be lost. Symptoms indicating a P0172 code can significantly impact vehicle performance. One common symptom is a rough engine idle, where the engine may struggle to maintain a steady RPM, especially when sitting still. Poor fuel economy can also be observed, as the engine consumes more fuel due to inefficient combustion. Drivers might also notice that the vehicle emits more exhaust gases or has diminished power during acceleration. Another telltale sign is the activation of the check engine light, alerting the driver to potential issues in the engine management system. Recognizing these symptoms early can help in promptly addressing the problem before it escalates further. In the first troubleshooting step for DTC P0172, start the engine and allow it to idle without any load. This step is crucial for establishing a baseline for the air-fuel feedback, AFFB, or short-term fuel trim. Using the Honda Diagnostic System, HDS, monitor the AFFB in the data list. If the value is 0.79 or less, it indicates that the AFFB is too low, prompting the technician to move to step 3. If the AFFB is within acceptable limits, proceed to step 2. This methodical approach ensures that each aspect of the fuel system is taken into consideration, helping to isolate the root cause of the rich condition. Step 2 involves reviewing the onboard snapshot to gather critical diagnostic data when the AFFB was at its lowest point. Parameters such as engine speed, vehicle speed, relative throttle position TP sensor, and accelerator pedal position APP sensor readings should be recorded. This data provides insight into the conditions under which the AFFB fell to 0.79 or less. After capturing this information, the next step involves driving the vehicle according to the recorded conditions to check if the AFFB still reads at 0.79 or lower. This ensures that any discrepancies under varying operating conditions can be identified and remedied. In this troubleshooting step, you will need to remove the mass airflow MAF and intake air temperature IAT sensor to inspect for any debris. The MAF sensor measures the amount of air entering the engine, and any blockages can lead to incorrect readings and contribute to the rich fuel condition. Look for lint, bugs, and other foreign materials that could obstruct the sensor. If you find such debris, it should be cleared, and a vacuum cleaner can be used to clean the air cleaner housing effectively. Once this is done, the MAF IAT sensor should be reinstalled, and the technician will proceed to the next step for further evaluation. The fourth troubleshooting step focuses on checking the fuel pressure under the same conditions when AFFB was recorded at 0.79 or less. Fuel pressure must be within specified ranges, ideally between 330 to 380 kilopascal. If the fuel pressure is within this range, it's an indication that the fuel delivery system is functioning correctly, and the process can move on to step 5. However, if pressure readings lie outside this specified range, the likely cause is a malfunctioning fuel tank unit, which would require replacement. This step is vital in ensuring the fuel system is delivering the correct amount of fuel to the engine. In this step, the engine should be started and held at 3,000 RPM until the radiator fan activates. This ensures the engine reaches proper operating temperature and allows for accurate readings. It is vital to check that the engine coolant temperature, ECT sensor, is above 158 degrees Fahrenheit. The transmission is neutral, and that all engine loads are turned off. With these conditions met, monitor the MAF sensor reading. The specifications for the MAF sensor at 2,500 RPM should be between 7.0 and 8.6 grams per second. If values fall outside this range, the MAF sensor may be malfunctioning, prompting an inspection of the air cleaner assembly or replacement of the sensor as a corrective measure. This troubleshooting step requires starting the engine and allowing it to idle while monitoring the AFFB. The technician should gently pinch the positive crankcase ventilation (PCV) vacuum hose to observe any changes in the AFFB value. An increase in the fuel trim reading above 0.79 indicates that the engine oil may be contaminated, affecting the overall performance of the fuel system and combustion process. If this condition is confirmed, the next step involves replacing both the engine oil and filter to ensure proper fueling and system functionality. If the AFFB does not increase, it suggests the engine oil is in acceptable condition, warranting continuation to the next diagnostic step. In this step, the focus shifts to the fuel injectors. These components are crucial for accurately delivering fuel into the combustion chamber. It is essential to replace the existing fuel injectors with known good ones and then operate the vehicle under the same conditions where AFFB was previously recorded at 0.79 or lower. If the AFFB remains at 0.79 or less, this implies that the injectors are not the source of the problem, leading to the next troubleshooting step. Conversely, if the AFFB increases, it suggests that the previous injectors were indeed faulty and must be replaced to ensure correct fuel delivery and engine performance. In this diagnostic step, the technician will replace the air fuel sensor, sensor 1, with a known good sensor, following the previous inspections and repairs made. After installation, operate the vehicle under similar conditions where the AF/FB readings were 0.79 or lower to re-evaluate sensor performance. If the AF/FB continues to remain at 0.79 or less, it indicates that the AF sensor is not the underlying issue, and further diagnostics should be conducted. However, if the AF/FB shows an improvement, it confirms that the AF sensor was indeed faulty and required replacement, thus restoring the correct monitoring of the air-fuel ratio. This step involves handling the fuel tank if there's a suspicion of fuel-related issues, particularly if a misfire is noted shortly after refueling. Start by removing the fuel tank unit and draining the existing fuel, followed by refilling it with known good fuel. Once the refill is complete, operate the vehicle under the same conditions where AF/FB was observed at 0.79 or lower. If the AF/FB still reads at 0.79 or less, it implies that the fuel itself is not the problem and will lead the technician to substitute a known good engine control module, ECM, next. If the AF/FB indicates improvement, the issue was likely related to the contaminated or poor fuel quality. After completing any required repairs, it is essential to confirm that the corrections have resolved the original problem. Begin this verification process by turning the ignition switch to the on position and resetting the engine control module, ECM, using the Honda Diagnostic System, HDS. Follow this by implementing the ECM idle learn procedure, which allows the module to recalibrate its settings based on the current engine conditions. Start the engine and hold it at 3,000 RPM until the radiator fan comes on. Then allow it to idle. Finally, recheck the AF/FB under the same conditions to confirm that it no longer reads 0.79 or less, indicating a successful repair. Preventive maintenance plays a critical role in avoiding future occurrences of DTC P0172 and ensuring optimal engine performance. Regularly check all engine sensors, particularly the MAF and AF sensors, to ensure they are clean and functioning properly to maintain the correct air-fuel mixture. Assess the quality of fuel used in the vehicle, avoiding substandard or contaminated fuel that could lead to engine issues. Additionally, adhere to recommended oil change intervals, as contaminated engine oil can affect the performance of the positive crankcase ventilation, PCV system, consequently impacting the fuel trim readings. Performing these maintenance steps can significantly reduce the risk of experiencing similar DTC issues in the future. The DTC P0172 diagnosis and subsequent troubleshooting illustrate the complexity of modern engine management systems and the importance of accurate diagnostics. This code signifies a rich fuel condition that requires thorough investigation, involving various components such as the MAF sensor, AF sensor, and fuel delivery system. Following systematic troubleshooting steps is crucial for accurately identifying the root cause and implementing appropriate repairs. Furthermore, the role of preventive maintenance cannot be overstated, as it serves to avoid the recurrence of similar issues and ensures optimal vehicle performance. A solid understanding of these aspects will equip Honda Civic owners and technicians alike to effectively manage the fuel system and maintain the health of their vehicles. Please like and subscribe to the channel. See you next time.